Hello Year 10. So this is the second lesson on 3D shapes, and we're going to be looking at the examples on page 304. So it's going to be quite a short video because there was only two examples there. So the first example, it says a cube has a surface area of 150 centimeters squared, and we're asked to find the volume. Now, with all of these types of questions, I always try and find a nice algebraic approach to solving it. So if I let one of the side lengths of the cube be x, then hopefully you're happy at telling me that all of the side lengths must be x. Yeah? So the base, the height, the length, all of them must be x. We know that the area of one face of this cuboid is x times x, so one face area is x times x, which is hopefully nice and easy, x squared. On a cube, I've got 6 faces, so then all 6 faces, so total surface area is 6x squared. Okay. If I'm told then that my surface area of my cube is 150 centimeters squared, I can then assume that 6x squared is equal to 150 centimeters squared. Now, this is solving just like normal. Divide by 6, so I get x squared is equal to 25. And then if I square root, I get x is equal to, remember when we take the square root, we have two solutions, don't we? We have the positive version and the negative version. In this case, we need to know that we have to reject the negative version because I can't have a negative side length. So therefore, x is equal to 5 because we are rejecting x equals negative 5 as we can't have a negative side length. And then to finish off the question, the volume of a cube is just base times height times length. So we know the volume is equal to 5 times 5 times 5, which is 125 centimeters cubed. I had to just quickly check the units there because I didn't remember if it was in centimeters or meters. So just make sure you are using the same units that they give you in the question. So that's how I would go about solving that question. There are obviously other methods. You don't need to use these x's, but I just think it's quite a nice layout in order to solve that question there. Okay. The second example, we're told that a 3D solid has this net, and we're tasked with finding the volume. Now in the book, they ask you to put the net together and draw out the 3D shape, but actually I think it's just a lot easier here to visualize and use intuition to go, well, I know that this must be a prism. Now you need to be able to tell me why you know that that must be a prism. So I'll give you a couple of minutes to think about that. If you want to pause the video here so you can think about it, please do. Otherwise, we can see, well, this shape here and this shape here are exactly the same. I've got the same shapes either side, and therefore the cross section is constant throughout. So if I was to cut anywhere parallel to my face, my front face, I would get the exact same shape throughout. Okay, so I know that this must be a prism, so therefore I can simply find the area of the cross section, which is the area of this shape here, and then times it by the length of my shape. So I know the area of my cross section so you need to be really careful here. So I've got a triangle, so I know it's half base times height, but we need to know what is our base and what is our height. So that's where in the last video I mentioned that the base and the height must be perpendicular to each other. So therefore either this is the base and this is the height, or this is the base and this is the height. So it doesn't matter the order in which we do those. So it's equal to a half times 4 times 3, which is equal to 6 centimeters squared. And then to find the volume of my prism, I can just do the area of my cross section, which is 6 centimeters squared, times the length of my shape. So volume is equal to 6 centimeters times 8 centimeters, which is 6 centimeters squared, times 8 centimeters, which is 48 centimeters cubed. Okay, so they were the two examples that we saw on page 304. So if you'd like to have a go at some of the more the application side of those questions on page 305, please do, and make sure you mark your work at the end. Okay, good luck with that, and bye-bye.